Well, we've been deep underground with that discussion, and as we heard, we were also talking about the potential of space. So now let's delve deeper into those new frontiers in space. We are, as we've heard, on the cusp of a satellite revolution, and Australia is indeed preparing to be at the forefront of the coming space age. But what will it look like, and what will the opportunities be? To discuss that, would you please make welcome Mr. Pierre Marchadier, Vice President, Business Transformation, Tech Sales, Strategy and Innovation from Dassault Systèmes, and our invited guest speaker, Dr. Mathieu J, Weiss, Managing Director, CNES, the French National Centre for Space Studies, Liaison Office Australia, India and South Africa. Would you please make our next guest welcome?
Ladies and gentlemen, good afternoon, or I should say, hello mate. I'm very pleased to be there, and I don't know if you've noticed that during the past days, some people in North America did put a car in orbit. So when we started this session, first of all, no need to say that we were very proud because this car was made with our solution, it's a Tesla car. And the second point is we ask ourselves about what can we do for Australia. And we said, okay, with Australia, what we can do is to put a caterpillar and a crawler on Mars. So that's the plan. But how can we do that? So I would like to show you very shortly, just prior to the presentation made by Mr. Mathieu J, some ideas about how Australia should consider space as an opportunity.
Terrestrial mining is the only real means of collecting the raw material required to support a modern lifestyle. This situation is likely to change in the future as natural resources on Earth are becoming increasingly scarce.
Dassault Systèmes provides solutions that help mining companies understand what's going on in their operations using the wealth of data they have about how their mines are operating, and then allows them to imagine what they're going to do in the future. The simple fact is we've already extracted the easy to get at ore. We're now going deeper, we're going further, and we're getting to ore bodies that are of lower grade, which requires more and more technology to be able to access. It's a natural thing that we're going to be looking further afield to find our resources. One of the things that's happening and that's actually becoming real is right out of the science fiction books, where people are starting to explore for resources on asteroids.
It is thought that asteroids may contain many of the same natural resources as there are on Earth.
Asteroid is made of the same things that the Earth is. An asteroid contained volatiles, that is, water and other liquids and gases. There are also minerals present on some asteroids that can be used both to support life and to develop the raw material for manufacturing.
As part of its continuing efforts to explore space, NASA has launched the pioneering Asteroid Redirect mission. This mission will eventually allow scientists to examine an asteroid and find out exactly what materials they are made of.
Exploration is part of who we are as humans. We have always, since the dawn of humanity, had this urge to explore. So we've decided at NASA to go visit a near-Earth asteroid and pick up a boulder off the surface of the asteroid and then redirect it back to near the moon where our astronauts can go visit it.
There are several emerging companies in commercial industry that would like to utilize asteroid resources. Some companies that are interested in mining and understanding what mineralogical components are on asteroids and whether they can return those compounds and minerals and elements here to Earth. Some of what we're doing with the Asteroid Redirect mission is providing an opportunity to answer some of those questions.
Asteroid mining is still theoretical at this point. But one thing that we do know is that we need to look further afield for the raw materials that our planet needs. At Dassault Systèmes, we can help the mining industry by providing 3D experience universes so they can visualize, design, and simulate their mining operations, whether they're here or there, or even on another planet.
So the point is, if we look at the trends right now in space, we are facing a real change of paradigm, for sure. So the point is, for example, that, you know, we've seen many new players in the space industry. And these new players, they do not have, let's say, a big legacy. They didn't spend the past 40 or 50 years creating a legacy on space knowledge. They all changed their paradigm using different kind of business model. That's something which is very important. They change the point of view. So interesting to see that the private companies are going into the business. Interesting to see that now when you do create something for space industry, you do it for multiple reasons with a dual approach, which is mandatory. It's also the fact that now people are looking for the price, the total cost of ownership of this program. They are not looking only to, let's say, a specificity or to a function or whatever. Before, as engineers, we were working with what we call the target to weight or the target to volume. Now we are talking about the target to price, which is important. Also, something which is interesting is there will be some opportunities in space transportation, because as of today, only 2 nations have the capacity to go in space with human people, China and Russia. Look at what happened with SpaceX. Look at what happened with Blue Origin, with all these new players. They are thinking also about suborbital, let's say, travels and trips. That's quite interesting to see that the fact that you can reuse a system can deeply decrease the total cost of ownership. So, when you look at what happened in the past months, or let's say, I should say in the past year, I give you 2 examples there. Blue Origin, which is a company founded by Jeff Bezos, the Amazon owner, and Zero to Infinity, a company, a Spanish startup, I should say, with no launch pad, no legacy, just an office in Barcelona. And these guys were crazy enough in order to rethink their business model using some different technologies and looking at the key, let's say, showstopper, if I can say, for their technology. And one of the showstopper is basically they do not have rockets. So for Zero to Infinity, it was a simple problem of how to go to the stratosphere. They took a balloon, and then they launched a nano satellite. And for Blue Origin, the fact was that they were looking for a way to reuse the hardware in order to decrease one more time the total cost of ownership. And they did this with our technology because in the virtual world, you can simulate multiple scenarios. And something good in the virtual world is you can press the undo button until the last moment. I should say that we are still working with big companies. And these big entities and big companies, I should mention, for example, the CNES, that you will know a little bit more after my presentation with Mathieu. For example, in 2004, we worked with them in order to provide them the right solution. And this solution were used by their team in order to create a little probe. This little probe called Philae started the journey in 2005 on Ariane 5, designed with Dassault Systèmes tools. And guess what? After millions and billions of kilometers, the little probe landed, or let's say almost crash landed, on an asteroid that no one knows the name exactly. So that's perfect to see that even during a 10-year trip, you can create something using, let's say, very, very simple technology, but also invention, innovation. So for the transformation, it's very important for everyone to understand the fact that you have to change your mind. And I think that for Australia, what's interesting is, let's say, to start in a way with a limited legacy in order to avoid to have, I'm sorry to say that, but narrow-minded. And when you look at how the newcomers, the new makers, the new innovators are working, they do not have limit. I had the opportunity to work with Blue Origin in the Mojave Desert, and it was a very, very nice place because it was a mix of young people coming from the MIT and old people, I'm sorry, senior people, coming from Rocketdyne. And these guys worked on Apollo 11. So can you imagine me being in the middle of them in the cafeteria, having very nice conversation about how to restart a super turbocharger or pump just to remove, let's say, just to restart an engine. Fabulous. So the point is, when you look at this transformation, when you look at these parameters, you have all the key elements to change the paradigm, even with the manufacturing. The fact that you can use additive manufacturing is interesting because then you can create a satellite, a system, or whatever, the right way without having, let's say, the pressure from the manufacturing. The challenges are very key. Zero fault, of course. So if you use simulation, you can challenge many scenarios. You can challenge many opportunities. And at the end of the day, you can consider even something which cannot happen. That's very important because when you put something on top of a rocket, it costs a lot of money, even if it's a nanosatellite. And you have to be sure that at the end of the day, it will be in the right position. Of course, the security is very important. The security is starting with the fact that you can have an end-to-end process, a digital end-to-end process to cover every point from the requirement to the physical, which is basically the product that you want to launch and the system that you want to use. Of course, something which is very important is the fact that now you can reuse. If you want to decrease the total cost of ownership, you need to reuse some elements. Something I would like also to mention is analytics. Because the end of the day is not to launch a satellite. The end of the day is to have access to information that you can use for your nation, for your state, for citizens, for security, for whatever. So once you gain all this data, you have to manage them. So how to move from big data, which is basically a mountain of data, to data science, which is basically how to use the data in order to have new services, new opportunities. So for Dassault Systèmes, and it's important for you to understand that, our mission, our goal is to support you with the best-in-class technologies that you can use in order to collaborate first. Yesterday, I had the opportunity to meet some space experts, Australian space experts, and they told me that collaboration is the key word. So how to collaborate with your peers, with universities, with big and small enterprise, with international partners, that's the key today, the collaboration. And thanks to the digital approach, you can accelerate and you can really increase your capacity to connect with people. It's also the fact that you can use the simulation in order to mitigate the different scenarios, just to be sure that you take the right decision. It's also the capacity, one more time, to accelerate. To accelerate means basically that with the technology today, and especially in aerospace and defense, using the digital suite gives you the opportunity to accelerate and divide by 2 sometimes the time you need in order to develop. So the world is flying with us. We are very proud of that. Every day, if you have the opportunity to be in a plane or if you have an opportunity to be next to a space industry, there are for sure many reasons to believe that it was designed, simulated, it was produced, it was even sold with our technology. So a lot of things to understand, a lot of things to integrate about the fact that Dassault Systèmes can be really your partner on the space industry. Thank you very much. Now I give the floor to Mr. Mathieu Weiss. Mathieu is the Managing Director in CNES for Australia, India, and South Africa. Mathieu, the place is yours.
Really great pleasure for me to be here today. Welcome everybody. Thank you Dassault Systèmes for having me here. So I represent the French Space Agency. It's been now 2 years that we engaged into a real process of reappropriating our relationship with Australia. We are here since quite a long time, but things have moved a lot since 2 years, and we will speak about. So, how do I change this? It's easier to launch a satellite, right? I have no idea. There's only one button, that's a laser. There's no other button. Oh, here. Okay. So, indeed, so I'm based out of India, and 2 years ago, I was mandated by our chairman to work with Australia, because we felt that there was something in its birth here, and we were right, since you see from the birth it has become something great with the at the Astronautical Congress 4 months ago here in Adelaide, the announcement of the future Australian Space Agency. So our homologue, so to say, our future partner. And in the meantime, we have opened a Space Mission Design Center in Canberra. So that is very concrete progress. And we have signed agreements with several actors in space, private actors in space, some of them here in South Australia. So we, as the French Space Agency, we are the main contributor to the European Space Agency. And our chairman chairs also the European Space Agency Council. So just one word about 22 member states and a budget of 5.5 billion euros. It's the world #2 space power. And in France itself, our budget for space is increased of 10% every year for the last years. So you see there's a real will in our country to stay ahead in this area. What you have to know is that 80% of the budget, the public money we spend, returns to our French industry via contracts. So nothing is lost in the system. It's really a very good model. And we host in France more than 40% of all the European space jobs. So a true success story. Indeed, I would like to say we do nothing ourselves. You know, in France we have great ideas, but we don't have a lot of money. So innovation, international cooperation is underpinning everything we do. Sharing costs, pooling talents, international cooperation will shorten our development cycles and enable more ambitious projects than what we could ever afford by ourselves. And I'm in India, so I can emphasize this point, which I live every day. Cultivating contacts with other cultures and other methods encourages disruptive approaches, and this is required to stay competitive. So, worldwide cooperation, let's start with our biggest partner, NASA. We just celebrated 25 years of operational services in oceanography. We have a future satellite in the tube. It's called SWOT, which you see on the picture. And this will again measure ocean surface heights. It's a very critical data for climate change surveillance. And with NASA, we are on Mars as well. So since long time, and we are already selection for the next missions. So few people know actually that the rover which landed on Mars 2011, Curiosity, its head, which is the MSL on the top right of the picture, its head and its heart are French. I guess there are few people in the room who know that. We are quite bad in communication, actually. So we are not really advertising it, but the head you see, which is a laser, which is able to analyze the content of a rock by 7 meters of distance without touching anything. It sends a laser beam, it analyzes the plasma by spectrometry, and they will say what is in the rock 7 meters away. So that is a French system. The HERT itself, where the things are analyzed, so what you gather on Mars, you will gather a little piece of soil, a little piece of rocks, and so on, and then it is brought by the arm of the rover inside, and the rover will analyze it in its own lab, and the lab itself is French as well. The rover is controlled half of the time from Los Alamos, and the other half of the time from Toulouse in France. So China, India, these are things that develop very rapidly. Now India has become our second partner after the US. It was traditionally Russia. There has been a shift. And with China, we started cooperating, which we are probably one of the only Western space agencies doing that. We have now a joint satellite in project with China, quite advanced now. And it's called CFOSat. And it's, again, climate. You will see in the rest of my presentation, climate is key. So to monitor waves and winds. Then we go with all the new entrants. We have a real appetence to meet new entrants, because what I told you, you will learn much more with people that do not resemble you than with people like you. And so we started to work with Israel, with Singapore, with the United Arab Emirates, which just announced 2 days ago a new joint satellite mission with the United Arab Emirates, South Korea, South Africa. We've entered into very promising developments. And with traditional partners like Russia, Japan, we keep also permanent contact, of course, and we do explore synergies wherever it is possible. In Europe itself, so I know the name of the comet, by the way. It's Churyumov-Gerasimenko, on which we landed. In Europe, we are developing Merlin, which is a satellite to measure methane together with Germany. We are developing together with the UK a satellite called Microcarb to measure carbon dioxide in the atmosphere. And this year we will fly to Mercury with the European Space Agency. So that was a little bit about CNES and what is happening in Australia. What have we done? 35 years, yeah, we are no newcomers. I didn't go back to Woomera, otherwise I could have put some years more. But 35 years because in the early 80s, we installed here a station, a reception station for our SPOT satellites. So these were the first French operational satellites for Earth observation. And Australia very much was interested in the data. And from the early days, you had a station here, and we are present in Australia since that day. Today, Australia is a central hub for receiving the data of the Sentinel satellites from the European Space Agency. You also have a really central role in operational altimetry since you host another ground station for our DORIS system. And there are more to come, so more ground stations. We are building more and more ground stations. And no need to say that the database system you have here, which is called DataCube, is state-of-the-art, it's the best in the world. Everybody agrees on that. So we are learning from you in how you analyze the data that you bring down from our satellites. So it's a good way to exchange. But you can see it's only ground. So you have a lot of things on the ground. We have the things in the air. So now the change is that we'd like to go with you into space as well. So launch services, of course, a majority of the 10 satellites of the Optus fleet, I think it's 6 or 7, were put into orbit by our Ariane rocket. NBN has sent all of its satellites with Ariane, so really, really good truth and truthful relationship. And that is us. That was last year in Alice Springs. So that's you know, we value our traditional players, our traditional partners here. That is with CSIRO, which is, until you will have a space agency, it's the closest partner, which is closest to us. And we have launched probably the most exciting astronomy mission of the year, last year, 2017, in Alice Springs. So this is a telescope, which is a 1-ton telescope with a 1-meter diameter mirror. It's intended to see the center of the galaxy that you cannot see from anywhere else. And you know, in the center of the galaxy, we expect that there is a black hole, and we want to see it. So we send this to, this is going just below space. So it's going to 40 kilometers high, and it costs much, with a balloon, and it costs much less than sending a space telescope like Hubble. And this, once it inflates, you can put a Cathedral of Notre Dame de Paris inside, so the thing becomes like 100 meters in diameter. So great success with Australia. This is a picture of the Mission Design Center in Canberra, I told you already. Here, signature with Fleet Space here in Adelaide. And this is another startup. It's a fancy story, not from South Australia, but I met them in Adelaide. It's the first 3D-made rocket engine, which an Australian student team developed in Victoria State. And they tested it in the barn of the father of one of the students. And so the guys were explaining this to me, and I said, hey, you guys need to meet my guys. And so we sent them to Paris. They came, and now they are exchanging. They will test now in our facilities, and great story going on. I like these kind of things, these kind of stories. Well, we have signed, space is now part of the strategic partnership between our two governments, and we intend to sign a cooperation agreement with the space agency as soon as it is ready. So space agencies in the 21st century, it's yeah, there has been quite a lot of changes. And it's a game shift. Well, Pierre talked about it. I mean, creating a space agency today is no way comparable of what it was in the end of the 50s, beginning of the 60s, when NASA, CNES, and the likes were created. It's completely different. So take the great challenge for space agencies today is climate monitoring. And indeed, to reach the targets of the Paris Agreement, you need to map precisely and independently the gas emissions, the greenhouse gas emissions. And only satellites can provide this capacity. So the One Planet Summit was called in Paris end of last year by President Macron. And at CNES, we have had a meeting the day before with all the international space community. So the heads of all the space agencies in the world joined in Paris, and they signed an agreement to create what we call the Space Climate Observatory, which is a kind of a United Nations of space agencies. The fact being that, you know, if you want to measure this independently, you cannot rely on one satellite, on one nation, on the satellite from one nation. You have to have satellites from several nations. And once you say, oh, that is Japan's satellite who measured this, then you have the next day an American satellite measuring it, and the next day a European satellite measuring it, and they come to approximately the same value. Then you cannot contest anymore that this is what you emitted. You have to know that today, what is given, the numbers that are given by the nations, by the states, are actually based on statistics only. So they will make a calculation on I have so and so much cars, I have so and so much factories, and so I emit that. It's completely declarative, and it's an estimation, it's not a measurement. So the first time ever I wanted to stress this, that we are depending on space to survive, so that's a little joke, but it is nevertheless probably the greatest challenge we have ever had in the history of astronautics, because if we do not do this, if we are not able to diagnose what is happening, we cannot propose any solution. So Pathfinder role for industry, we are from development to flight demonstrators, investing in what others, in what the private industry would not invest. So we do really the work ahead to prepare the ground for the private industry. We are mentoring new entrants, and especially we like new space. We are very close to all the startups, to all the innovative, dynamic guys. We have established a network of users because, you know, we have to, as government people, we have to explain to train companies, to mining, to whatever, all the sectors of health and agriculture and so on, that they need space and how they could use space. And we have to do it in a neutral way so that these communities start to organize themselves, so that when the industry is ready, they can immediately have networks of users that are able to work for them, and that constitutes of obviously new markets. So a spirit of symbiosis means, be it internationally, working with people overseas, or be it between traditional space and new space, we try to learn from each other. So the new space people, startups, use our facilities, but we learn as well from them. We change our methods, we adapt to the flexibility they have, the new kind of, like the new spirit and so on. And I think we have really to make bridges between your new spacers here, which are really good, and the new spacers back in Europe, in France. And it may give them also a critical mass if we join them together. So space, this was taken in Alice Springs, by the way, with the Milky Way. Space spirit of universality is the fact that in space, the international cooperation, freely available data, was something that we had since the start, the beginning of space, nothing new for us. Way before these concepts reached other sectors of industry. And the global essence of space, the spirit of universality, that needs to inspire us in what we are doing, because space is showing us the way to cooperate. And my last slide, we can invent the future of space together. You see, I have put the CNES logo. I'm waiting for the logo for the other side. And, well, it just takes a will. Thank you.